Welcome Algebra 2 students to our video notes lesson on section 3.4, where we are revisiting the three equivalent forms of a quadratic function. You may remember we were together for a similar lesson back in Unit 2, and that was on section 2.7, where we looked at how to graph a quadratic function in any one of these three forms. Today's lesson, though, is focused more on what makes them equivalent, or the equivalency between them, and how to convert from one form into the other. Before I get to that, though, let's just revisit what makes each form unique. So standard form is the one without any parentheses in its equation. So that means that everything's been multiplied out and all of the like terms have been combined. Once that happens, whatever number is left over without an x is the y-intercept of the graph. So standard form is known for revealing to us what the y-intercept is. It's that constant at the end, the one with no x. In vertex form, what we have is a set of parentheses squared. So whenever you see that, anything parentheses squared, then you know you're in vertex form. And then also when you're in vertex form, whatever number is inside the parentheses with x would be your x coordinate of your vertex. Whatever number is being added or subtracted outside of those parentheses squared would be the y coordinate of the vertex. So if you put those two values together as an ordered pair, you get the vertex on the graph, which is perhaps the most important point on the graph of a parabola. So that's why vertex form is probably the easiest one to graph in, because it gives you the vertex right in the equation. Intercept form is the one where you see two sets of parentheses, or I should maybe clarify and say two factors, because you don't always need a set of parentheses for a factor, especially if your factor is just x. So what I mean by that is you might have something that looks like this. A times the first factor of just x times the second factor of x plus or minus something. This is also an intercept form. It doesn't have two parentheses, but it does have two factors. So another way we can think of intercept form is we can think of that as factored form. If you have two factors present, then you know you're in intercept form or factored form. And then what those factors tell us are the x-intercepts of the graph. They are the values of x that when I plug them in to the equation would make the y-coordinate 0. And so those are the x-intercepts of the graph. So that's what we learn from intercept form. Now, what makes these forms, or what do these forms have in common? They each have the same a value. So the a value in each of these forms is the same. So right there we can see that they are connected. There is a connection between these three. And the first connection we're going to visit is how to go from either vertex form or intercept form into standard form. That's probably the easiest one to do, because all you need to be able to do that is just some basic algebra skills, some distributing skills, using order of operations to make sure we do things correctly, and then combining like terms. That's all you need to go from vertex or intercept form into standard form. So let's take a look at that with number 1. So in number 1, we can see this one is in vertex form, and the way I know that is because it has the parentheses squared. So what does that mean to have a set of parentheses squared? What that means is that I'm actually multiplying that binomial to itself. It means I have two of the same binomial being multiplied together, which is why it's squared. And so if I want to basically get rid of those parentheses to get into standard form, remember standard form is the one with no parentheses, then what I need to do is just multiply those factors to each other, which is going to require some distributing or foiling, right? When you're multiplying two binomials, we need to FOIL. So I'm going to start by doing that, because I also need to follow the order of operations, which says that you need to take care of the exponent first before you multiply by 2. So I'm going to FOIL first before I distribute the 2. Okay, so by foiling I get x times x, x times negative 5 times x, negative 5 times negative 5. I'm going to go ahead and combine those like terms inside there too before I distribute. So at this juncture, I now am going to do the second thing in the order of operations, which is to multiply. I will take that 2 and distribute it to each of the three terms in that remaining trinomial. Then what happens is these like terms reveal themselves, and I can go ahead and combine them. So my finalized standard form would be 2x squared minus 20x plus 56. So now that I have FOILed out my binomial, distributed my 2, and combined my like terms, I now have an expression that looks like ax squared plus bx plus c, which means I can now identify my y-intercept. My y-intercept for this graph is 56. Earlier, when the equation was in vertex form, I could identify the vertex. The vertex of this graph is at 5, 6. And also what I notice is that each of these graphs have the same a value, right? When it was in vertex form, the a was in front of the parentheses squared. When it's in standard form, the a is in front of x squared, but it's the same a value. So let's take a look at the graph to further see how these equations are connected. So what you can see is I have entered in both of the equations, the one in vertex form and the one in standard form. If I take off the one in standard form, you can see the one in vertex form is basically graphing the same parabola. I can put the standard form on, take off the vertex form, and again I see the same parabola. So two different equations are basically giving way to the same exact graph of the same exact parabola. Now notice that when I take off the vertex form and I'm just in standard form, I can see that this equation still has a vertex of 5, 6. Even though I'm not seeing that in my standard form equation, that doesn't mean that's not the vertex. It just means that the standard form is highlighting a different point on the graph. The standard form shows us the y-intercept. So if I go all the way up here to 56 on my y-axis, I can see, okay, this graph has a y-intercept of 56. That's what the standard form is highlighting in the equation. But notice that in the graph, it's still the graph of a parabola with the vertex at 5, 6. Okay, so similarly, let's say I'm looking at the graph of the equation in vertex form. So naturally it has a vertex at 5, 6. That's shown to us right here in the equation. But just because this equation is written in vertex form doesn't mean it has a y-intercept of 6, right? This is the y-coordinate of the vertex. This equation still has a y-intercept of 56. If I scroll all the way up here, I can see, okay, yeah, there's the y-intercept of 56. It just wasn't being shown when the equation was written in vertex form because vertex form highlights the vertex. The point is, even though these equations look different, they are referring to the exact same parabola. They're just highlighting different parts of the parabola. So the vertex form highlighted the vertex. The standard form highlighted the y-intercept, but they are basically the same equation for the same parabola, just written in different forms. So why don't you guys try going from intercept form, that's this one, into standard form. Basically, all you'll have to do is FOIL these out and distribute the negative. Try that and then check your answer. Okay, so upon FOILing and distributing, I end up with, so I have the same a value of -1 that we had originally in the intercept form. And then I get negative x squared plus 2x plus 80. So I notice I have a y-intercept of 80 once I get this in standard form.